Unreal's newest update, Unreal Engine 5.3, just released, and it is a big deal. The main reason is Nanite landscapes. When Unreal Engine 5 came out, it introduced a revolutionary new way to render geometry called Nanite.
What is Nanite?
To briefly sum up Nanite, every object you see in computer graphics is made up of tiny flat planes of geometry called polygons.
I understand this. Look at all these triangles. That makes a shape. Get it. I get it.
The more polygons you have in your environment, the longer it will take to render. This is why video games have made a system called level of detail.
Further something is away, the less polygons there are. I get it, right? Because you can't tell. You don't need max definition of something super far away.
Or LOD for short. The further away an object is from the camera, the less polygons it will use to render that object. This makes
right. So yeah, look at the top, like it's nice and smooth. Oh, a little jagged. Oh, really jagged. But if this thing is a mile away, you can't tell the difference.
Games run faster, but we are limited in the amount of geometric detail we can have. Nanite fixes this because it uses dynamic level detail, which means you can have an object with millions of polygons without any LODs.
Well, I don't understand.
Which means you can have an object. Nanite games run faster, but because it uses dynamic level detail.
Dynamically changing the level of detail. How is that different?
We don't make mistakes.
How's that different?
We have happy accidents.
Isn't this working dynamically too? I guess I don't understand.
Which means you can have an object with millions of polygons without any LODs, because the geometry deforms, lowering the amount of polygons on an object.
What?
Any LODs, because the geometry deforms, lowering the amount of polygons on an object.
The geometry deforms, lowering the amount of polygons on the object. I don't know what that means. Unfortunately, I'd like to know what that means, but it just results in better graphics for less computation. But I'd really like to know what that really means.
A good example of Nanite in use is this city. If I come up to lit, Nanite, triangles, we can see Nanite in action.
Polygons, sure. Normally you have to make lower quality objects. You have to the maker of the environment has to have an object in its highest detail and then say clickety click click click, re-render lower, and they have to do that manually. And then Nanite just does it automatically by saying, here's your highest level version of the object. And then if it just happens to be far away, we'll just render the lower version automatically.
Every color is an individual polygon, and there are millions of them. The biggest issue with Nanite is that when it released, it only worked on
So you have to have points where
and there are
the level of detail switches. Do you have to define that, or is the game engine defining that? Shouldn't the game engine decide that there's too much information on the screen, frame rate's lower, and automatically switch? I guess that's what Nanite does.
millions of them.
So basically, super simplifying the workflow in order for devs to have to spend less time doing tedious stuff.
The biggest issue with Nanite is that when it released, it only worked on non-moving static objects. It was only really good for objects.
Normally, you have to decide the LOD stuff for yourself, which that's incredibly. That sounds incredibly tedious. Takes forever. Okay,
like rocks and cliffs. This changed with the Unreal Engine 5.1 update. It introduced Nanite foliage, which gave us the ability to create forests with an unlimited amount of detail.
Right, the procedurally generated landscape tool. Click, drag, boom, done. You don't have to make individual. It's procedurally generated. There's randomness, etc. Yeah, it works. It works incredibly. It's because I've used it for my own this scene right here. This is all procedurally generated. I've added stuff in and done different stuff with it. But it's all basically like this scene. This is my scene I built with one of the marketplace things I bought. But there was kind of a base, and then I just added my own stuff to it procedurally, and so I think it looks pretty good. So that's a tool I used. But now this 5.3 allows you to do it to moving objects.
Here's a world with over 100,000 trees.
Oh no, I'm sorry. This was not Nanite. This was just procedurally generated landscape, not using Nanite. 5.3 enables Nanite for it. So there's like the dynamic LOD. Okay, I got it. I understand.
without any LODs. But landscapes, which is the biggest part of any environment, was still missing nanites.
Right.
Landscapes allow us to create large open worlds easily. Using the tool, we can sculpt, add height maps, and paint different
Yeah,
materials
I've used the same
quickly.
tools
This
before.
means landscapes were stuck using low resolution geometry, and it hurt our game's performance because Unreal has a hard time rendering non-nanite objects. In all the tech demos Epic Games released, to avoid these issues, they didn't use landscapes.
That's why landscapes always looked incredible, but everything else still looked like normal and real.
Instead, they faked landscapes. This desert ground isn't actually a landscape. Instead, it is a bunch of nanite objects stacked on top of each other to make it look like a landscape. Finally, in
Whatever gets the job done.
5.3, Nanite officially supports landscapes. To activate Nanite, select your landscape, and then within the details panel, enable Nanite, and then build data. Now that it's enabled, we can watch the geometry dynamically deform. It is that easy to enable.
So deformation is what level of detail is. As an object moves further away, you used to have to do that manually, lower the level, deform the object manually using different renders. Now Unreal just handles it all automatically, so devs can spend more time making new stuff instead of all this tedious stuff.
Nanites on our landscapes. In the first version of UE5, we made this village on the channel, but at the time, the only objects using nanites were rocks and the buildings. Now in UE 5.3, the entire world is nanite. There isn't a single object that isn't using nanite. The only objects in the first version of UE5, we made this
Look at the
village on
water.
the channel.
Can you make the water nanite? See, if these has better water.
But at the time, the only objects using nanites were rocks and the buildings. Now in UE 5.3, the entire world is nanite. There isn't a single object that isn't using nanite. This means we can get an infinite amount of detail
this looks
from our
average.
environments, and the performance is a lot better. Nanite landscapes can now also use tessellation to add more detail. In UE4, we had tessellation, which allowed us to create displacements from a high texture.
Didn't they used to call this bump mapping back in the Halo days?
When Unreal Engine 5 released, it was removed, but now it is back and it is using nanites. This means we can change objects from the material editor. We have a brand new input called displacement.
Right. So instead of having multiple polygons for this surface that is clearly, not a flat plane, but it's got bumps to it.
Where the high texture goes.
This little 2D image of black and white. White indicates raised surfaces, black indicates lower surfaces, therefore creating ridges and textures so that when light hits it, it creates casted shadows. It's still one polygon using what I displacement or tessellation, whatever they called it.
Tessellation can convert any simple mesh into an object with thousands of polygons just with a texture.
Now,
Here's an environment with a landscape that isn't using displacement. The world feels kind of flat, and here's the same landscape with displacement.
but they're adding polygons through displacement, but it's only using that 2D map. So I don't know how that affects like efficiency for the engine. Because in the end, those are just polygons, right? Like that, it's like automatically creating polygons, but it's doing it in a way that I think again saves you time, is good for your workflow, etc. Because you can just use a flat, 2D map to give you the result of what ends up being polygons that you don't have to create, right?
The ground has depth to it, and it looks a lot better. Everything you see on screen, except the plants, is the landscape. All the rocks, twigs, and roots are not objects. They are a high texture, and whenever I make a change to my landscape, the nanite displacement remains in effect. For the first time in gaming, we're not limited by how many polygons are on screen. We can have infinite geometry everywhere. The next major feature is better volumetric fog
and that's
geometry.
Key. Infinite geometry everywhere, because the engine automatically deals with optimization, which will make stuff be able to dev so much faster.
Everywhere. The next major feature is better volumetric fog and smoke. Unreal's had volumetric fog for a while, which gives us the ability to have realistic light scattering in fog and smoke. To enable volumetric fog is easy. You just have to click volume.
Not really true. Draw calls are still a thing. Well, I think he meant not from the, you can't view infinite geometry, but you can design a world with infinite geometry, assuming, yeah, I mean, I guess you're still limited by, you know, in the end, you don't have to worry about optimization as much. There's other things you have to worry about optimization with, but like not, like I'm not sure what draw calls are, but yeah, it's you not having to worry about LOD nearly as much.
Volumetric fog within the height fog to turn it on. Now we get dynamic fog that interacts with the lighting. So I can move the sunlight around and you'll see those God rays change direction. It is the secret to make any of your environments stand out.
I feel like this video should have been recorded in like 4K because it looks a little blocky.
Here are before and afters of an animation with and without volumetric fog. The world feels more realistic and it looks visually more interesting with fog. The only issue in Unreal was that it was problematic to create finely detailed fog.
Oh yeah, in my scene, I tried to create like a little fog bank and it was terrible. I was like, I'm giving this up. I need to hire somebody.
It can only be used to create large splashes, and it was hard to use volumetrics for complex shapes like explosions. Instead, explosions and smoke had to be faked with
That's
billboards.
flat.
Billboards are just a flat surface with an
You
animated
can tell.
texture.
You can tell.
You can see
it's so
that
trash.
This is just one single plane. The smoke isn't actually 3D. Obviously, this doesn't look the best because when I move the lighting in my environment,
Yeah,
the
trash.
smoke stays exactly the same. We don't see any changes because after all, this is just a flat 2D texture. In 5.3, sparse volume textures fix this. We can now import complicated volumetric simulations from programs like Jenga FX. Here is a sparse volume explosion.
Okay, this must be an example because that looks like trash. But it's still 3D, so cool. But that particular low-res thing that you're showing me does not look that great. Fog bang is what I call my pants.
Imported from Jenga FX into Unreal. And if I pause the simulation, you can see it is not
Better.
being faked by billboards.
Better.
This smoke simulation is completely 3D.
Too fuzzy.
If I move the light around, it will dynamically change the way the smoke looks.
Cool.
The smoke is able to cast shadows onto itself.
Why does it look like it's 480p? Right.
We can even use sparse volume textures to represent clouds. And what's amazing about these clouds compared to Unreal's default cloud system is that I can move them around and rotate them. So I get full control over where my clouds are in the sky. And if we zoom out, we can even see that these clouds are massive objects that I can move around and place them exactly where I want them to be. Volumes can even
I'm not sure how clouds currently work, but I guess they're incredibly limited.
replace some particle effects. For example, this fire here is very similar to the explosion.
Flat.
Where if I go into wireframe view mode, it is just a couple of 2D planes that simulate a fire animation. And then if I look down directly at it, this effect immediately breaks. And now here's
Wacky.
that particle effect, but it's replaced with a sparse volume texture.
And I mean, this is way better than the fog one because that actually looks like a way more legit fire.
This fire is now completely in 3D. It's not a 2D plane that's facing the camera. So if we look at it from the top down,
Way
the
better.
effect doesn't break.
This needs a slightly higher frame rate. Volumetrics are very heavy resource wise, so using billboards in the game. Oh yeah, I imagine like there's gonna be certain situations where you're gonna want some badass looking fog, smoke, clouds in a certain situation, maybe that has like not a super complex, maybe a simple environment scene where you could maybe get away with it. But yeah, I'd imagine like you're not gonna do it in the middle of a competitive, battle royale. 100 players are dropping down into Misty Mire, and you're not gonna use volumetric. I mean, maybe Fortnite, but yeah, cinematics for sure. Yeah, something pre-rendered or more controlled.
This fire is real and it exists in our world. Another major feature is that we can now create animatable characters directly in Unreal Engine.
Wow. Yeah, that's never been in Unreal. You always had to import it from other programs like Blender or.
In Unreal, we have been able to create rigs and animate characters. This animation you're looking at right now was animated entirely in Unreal. It wasn't created in another program like Blender or Maya. The biggest part missing in the character creation workflow was skeletal mesh.
That was a sussy movement. But again, if Blender does it good, how does it help Unreal? How does it help devs if Unreal does it well? If Unreal starts doing it, how does
Blender or Maya?
How does Unreal do it? I guess it's because it's all self-contained. I guess you don't have to learn another program.
Biggest part missing in the character creation workflow was skeletal mesh editing, which is the process of creating bones in a character. UE 5.3 adds a skeletal mesh editor.
One license.
This means we can create bones and weight paint directly in the editor. It is now possible in Unreal through modeling, weight painting bones, rigging, and animating using Sequencer to create an entire
animation. What am I looking at? Animation must be so complex. I've never wanted to animate anything.
character just using Unreal.
Viewer tools, no context switching, imports, right? Import exports. Yeah, I've had to deal with that with my own scene. This scene, Studio X Plus in chat built me this TV and stand, and then I just slap a video on top of it. But it's just so tedious and time consuming. And I did have to figure out how to import it from Blender into UE5. So yeah, I guess that's true. That would help my own workflow.
We also get a new cloth editor to create realistic simulations for
keyframes. I'm an animator. Oh, interpolation between keyframes. Right. But it still looks stupidly complicated. Unreal doesn't do it well. Unreal's extra modes are underdeveloped, not very efficient. Right. But over time, they'll get better, right?
flows. Users can define exactly how a cloth simulation can interact with a character, and then artificial intelligence will bake that interaction into an animation.
As an animator, animation takes all keyframes. You mean every frame is a key? Every frame is a keyframe, therefore, what's the point?
Reflections also got a major update. If you don't know, Unreal Engine 5 introduced a brand
hyper realistic. Okay, not quite. Never mind. A little muddy, a little
new lighting system called Lumen. Lumen gives us dynamic bounce lighting in real time. It's important to know that bounce lighting is also called global illumination. Global illumination is a process of light rays bouncing around, illuminating your entire world. Before Lumen, game developers faked global illumination through a process called light baking. Light baking is rendering bounce lighting before the game is played.
Therefore, if anything moves, screwed up.
This render is then stored in a texture called a light map, which is then overlaid on top of the world to make it look like the light is bouncing around in real time, when in reality, it's just a pre-rendered texture. But now the problem is that global illumination isn't real time. As soon as I make a change to our light map, it is no longer in sync. We have to rebake the entire environment all over again, which is time consuming. This is why Lumen is a big deal, because it is true real-time global illumination. We don't have to bake our lights, but the downside is that Lumen is very expensive.
Oh yeah, because now you're having to reprocess those reflections, that lighting, every single frame.
Not every computer can run it because it is computationally intensive. This is why Unreal games like Valorant still use baked lighting. It is a competitive game, so every frame matters. If we open up a Valorant map...
Valorant's on Unreal? Wait, who makes Valorant? Doesn't Riot make Valorant? Riot's using Unreal?
Unreal, you will see it using baked lighting.
Womp.
If I move an object, the light doesn't update until I rebake the environment. Even though Lumen exists, a lot of games still have to use baked lighting because it is just more performant. You could get 120 frames with baked lighting. It's hard to get that many frames with Lumen. Hardware hasn't caught up yet. This environment is using baked lighting, and one of the biggest issues with baked lighting is that it doesn't have any reflections. You'll see that this entire environment is broken because the reflections aren't working. And we can fix this by manually adding in reflections by using a reflection capture within Visual Effects, Sphere Reflection Capture. This will capture a 360-degree texture of my environment and then project it onto any reflective surfaces.
Oh, that's how that works. Okay.
The workflow to get reflections everywhere is that now I have to create another reflection capture and move it to where there's a bunch of reflections.
Oh, God.
And then I have to create another one.
Oh, God.
And then continue the process throughout the entire environment. And if we have a large environment, this process can be very tedious. Here's an environment that's using Lumen and
Okay. Looks weirdly muddy.
reflections work immediately. We do not need reflection captures. But the issue is that we
I mean, I don't know, maybe it's just the quality from YouTube, but it just looks, it looks, I don't know, maybe it's my LASIK vision. Actually, I just went LASIK for a sad story.
had to use Lumen global illumination, which hurts our performance. In 5.3, we now have the ability to use Lumen reflections with baked lighting. So we do not have to use Lumen global illumination to get Lumen reflections. To get this feature, go to the post-process volume and set global illumination to none. So we're using the baked lighting and not Lumen, and then set reflections to Lumen. Now we're using baked lighting for global illumination and only using Lumen for reflections.
So that's cool, but it seems like when you make things global, you also take away some control from the design. And so I could imagine some designers not liking this, you know, one shoe fits all global style, and that it would need the ability to be like heavily tweaked in order to get exactly what you want in certain situations.
We get the high performance of static lighting with the accuracy of Lumen reflections. Plus, we no longer have to set up reflection captures. Also, Lumen reflection now supports multiple bounces. So let's say we have a mirror right here, and then across the hallway, we have another mirror. Notice how we can't see the other mirrors in its reflection. That's because
Time for infinite mirrors. Time to crash Unreal, baby.
we don't have enough reflection bounces. So if we go back into the post-process volume under reflections, we have a brand new setting called max reflection bounces.
Nine.
If I set this to 2, now we can see the reflections.
Dude missed an opportunity. You got those are rookie numbers, dog. You pump those numbers up.
The modeling mode's user interface got a facelift, and now it is a lot easier to use. All the tools are neatly organized into categories, and let's say there's a tool I use a lot, like Displace, then I can right-click and add to favorites, and now I can quickly access that tool within the favorites tab.
That seems like something that should have already existed, but continue.
Masked materials like foliage are now 20% faster, and there are more shadow options for Nanite to help optimize shadows. Unreal's shadow system, called virtual shadow maps, are right now the main bottleneck to foliage. So this gives us more control over what types of shadows should trees cast. And finally, a big update for Mac users, Nanite is now supported on all Apple M2 devices. Finally, Apple users have access to both Lumen and Nanite. When UE5 first released,
Good for
it didn't
them.
have either. The entire world
shoot.
is Nanite.
No.
There isn't a single object that is to both either feature. This also means that Unreal Engine 5 with Lumen and Nanite will be able to run on the Apple Vision Pro. The programs you're developing now on Unreal could be used for the Apple Vision Pro in the future. The possibilities are endless for Unreal. These are all the major changes to UE 5.2, but these are just the ones I think are important. Of course, there's a bunch of other changes you can check out by going to the Unreal release notes. Unreal is more important than ever because half of all next-gen games are being made in UE5. There is no better time to learn Unreal Engine than now.
I think
Luckily for you, I have an entire free
Okay.
course right here on YouTube, which goes over the essentials to learn UE5. You can
So
learn
as a
how to create
UE5
this world you
teacher,
see right now. You can check it out.
um,
Link in the description below.
I'll link this. There's a video. I'll put it in chat.
Unreal.
I think that these
came
updates
out, it introduced
almost
a brand new
feel
security
like
to Unreal
a
called Nanite. To briefly
these
sum
updates
up,
almost feel
the
like
object you see in computer graphics is made up of tiny
I don't know. I'm not in the biz, but as someone who like plays a little bit with Unreal, it almost feels like these are kind of like a marketing tool
This is why video games have made a
and
level of detail
good
more LED
for
The further away an
people who maybe better for people who are like experts. Like I'm not an expert, but I find all these things really interesting because it lets me not have to learn all these things that people who currently use old style or the current style of game design. I don't have to learn all that crap. I can just click a box and it's like, boom, global illumination, global reflections. And it may not be perfect and it may not be the best, but I've not had to take hours and days and weeks and months to learn it. I just click a box, drop an object in, and it's good to go. And it may not be as optimal, may not be as good, but it's so close to being where it needs to be that for what I need, it's fine, absolutely fine. So yeah, I can't wait for 5.4.
Landscapes allow us to create
Woo!
large open worlds easily. Using the tool,
Rip2 is a Unreal Engine rookie. All these tools have been great since I don't have a great traditional pipeline with other software. That's what I was trying to say, but you said it better. Nice. Lowering the skill floor to make it more accessible. That's what I was trying to say. You said it. Man, why does everyone talk better than me? I need to change jobs.
This desert